Okay, I already started this practice problem, but I'm going to go back and work through it with you guys. Okay, so when you're reading this one, a plane flying horizontally at 350 meters per second. So since it says flying horizontally at 350 meters per second, that's my first indication that I have found a variable that I need. This is my x velocity. This releases a package at an altitude of 1,500 meters. So altitude, what does that tell us? How high it is. So why don't we draw a little picture to help us visualize this? So if I'm a little airplane, okay, that means that it is going at your Vx at 350 meters per second. The altitude is the height. That is your dy. We just said that was 1,500. Okay, so I'm going to go ahead and go over here to my template, and I'm going to fill out my first known is that Vx is 350 meters per second. And then we're going to fill out our second known is that our altitude or our dy is 1,500 meters. Okay, so now let's go ahead, now that we just pulled these out of the equation, let's go ahead and fill in the other knowns since we know some basic properties of free fall. Okay, so for my y-axis, I know that an object from rest, when it drops, has an initial velocity of 0, and I know that it has a gravitational pull, so a negative acceleration of 9.8 meters per second squared toward the Earth. Okay, and then it's asking us how long will the package take to reach the ground. So we are trying to find the time. Okay, so what's really cool though is that the time it takes horizontally for the care package to reach the ground is horizontally is the same as the time it takes to reach the ground vertically, because regardless the package is just hitting the ground, so the time is the same. So what I'm going to do now is I'm going to figure out which equation I have enough information to use. Okay, I know you have these in front of you, but remember, these are your equations for this unit. So let's evaluate. We know, let's talk about the knowns that we do have. We are going to try to find our time. What information do we have enough of to find? Do you think this one will work? Do you think okay, so y'all say the second one? Let's look and see what happens. So if I decide I want to use dx, exactly. So when you try, you basically try it if you think that's right and see what happens. Vxt. Well, if you try to find your time this way, notice that you have two unknowns, so that wouldn't work. You might try it at first and say, oh, whoopsie, wrong one, which is no big deal. That's what we do all the time. So if you try that, no biggie. It's not the right one though. You're looking for time, so you're probably going to want to find the equation that's already easier for you to use, right? This one's already got t solved for you. So even though this one and here's this one, those two are the same, aren't they? It's just that this one is worked out to get dy by itself, and this one is worked out to get t by itself. Awesome. So we are going to want the one that has t by itself because that is our unknown. So okay, so now let's plug and chug. Our time remember, you can't put a negative in an absolute value, in a square root function, so we're just taking the absolute value of that. Work this out in another class. Let's check it though, see if I'm right.
Are you dead, Brian?
I got 17.5 seconds. That's what I got one the other day too. Is that what everyone else got? Yay! Good job. How far will it move horizontally? Okay, so now it is asking us for what? How far it will move horizontally. Okay, so our new component down here is we're trying to find dx, and guess what else we know? Time, because the time it took to fall horizontally is the same time it takes to fall vertically. I'm always used to velocity equals distance over time. My bad. Y'all are doing it different. Y'all are doing distance equals velocity times time. I always go straight to that. Okay, so distance, Vx is, where to go? Up there. 350 meters per second times our new number, 17.5 seconds. Multiply those together.
No, that's not right. 6,125.
That is correct. 6,125 what? Meters. I do not want to get in trouble with my professor, or my teacher rather, and forget to write my units. Okay? Okay, number 2 on the horizontal projectile example. In many locations, old abandoned stone quarries have become filled with water once excavating has been completed. Blah, blah, blah. Anyway, while standing on the quarry wall, Clarence tosses a piece of granite into the water below. He throws the rock horizontally at a velocity of 3 meters per second. It lands in the water 17.5 meters from the base of the wall. Let's draw this. Okay, that's a lot of words we don't need, so let's just draw it. Okay, Clarence is chilling. Woo! Okay, he is on top of a quarry wall. I went to a quarry once in college in Athens. Apparently I wasn't supposed to.
Why?
Apparently it was trespassing. Okay. He tosses a piece of granite into the water. He throws the rock at a velocity. So look at this horizontal component right here. Okay, so that goes right here.
And then you go up and down at 17.5.
Okay, so we were just saying that 3.0 meters per second is horizontal, and it lands in the water 17.5 from the base of the wall. Is that my height? Or is that where the rock lands, away from the base? You see how that is worded in such a way to tell you that that is the x-axis distance away? Okay, so this is his granite rock splashing right there. Splash, splash, splash. Okay, so it's asking us how long it takes to hit the water. So it's trying to ask us the time. Well, the beauty is that the time is going to be the same for x and y. Look what else I can fill in right here, gang. Do y'all know an equation immediately that we could use? The only equation available for the x-axis, period? I love it when they give us this kind of equation for first. Okay, so we know that 17.5 equals 3.0 times t. So now I just got to get t by itself. Divide both sides by 3. T equals 5.8 seconds. Sweet. So 5.8 seconds. So now watch what they can ask me. How high is the quarry wall that Clarence is standing on? Now we can discover dy because we know time, because the x time is the same as the y time. When the rock lands, it lands. It doesn't land different over here and then land different over here. It doesn't. The rock lands when it lands. So what equation can I use now? GT squared. So I'm looking for my dy. Okay, so that's 1/2 times 9.8 times t. We said was 5.8 squared. So D equals 164.8 meters. Now, if you stuck on a negative right there and you got a displacement of negative, I wouldn't count off for that because you are going down compared to your starting point, right? You're going in that negative direction, but you can leave that negative off here because really the distance of how high something is what it's asking us. So it's technically a positive number.